Hello everyone, myself Anil. Today I'm here to talk about the introduction about the theory of computation, which is the topic of theory of computation. Abstract. The theory of computation is an essential aspect of computer science and mathematics, primarily focusing on the formalization of problems that can be computed and how efficiently they can be solved. It is divided into three key areas such as complexity theory, computability theory, and automata theory. Complexity theory measures the difficulty of solving the problems, and computability theory explores which are all the problems can be solved algorithmically, and automata theory will examines the abstract machine and it will computation the performance. The study of computation provides a mathematical foundation for understanding what can and cannot be solved by the machines. The foundation helps to distinguish between the solvable problems and those that can be efficiently computed, and problems that may be unsolvable or require excessive computational resources. In the practical application, this field supports the development of software and hardware for the various computational tasks. Each branch of the theory of computation serve as a different purpose. Like complexity theory focus on the classifying the problems based on the resource required, and computability theory defines what problems are algorithmically solvable, and automata theory formalize the concept of computation through models like finite automata and turning the machines. Introduction. The theory of computation is a fundamental concept in computer science, forming a basic for understanding the algorithms and their limitations. At its core, the theory deals with the how the problems can be structured or solved and be analyzed using the formal methods. The classic theory introduced a machine that processes the input strings and to an output string, where the simplest form involves a binary decisions. A central part of this theory is the idea that any computer program can be described as a finite string of characters. This abstraction enables the classification of algorithms and problems into different categories based on the computational complexity and solvability. Understanding the boundaries of computation helps in the scientists and engineers to determine what kind of a problem is feasible to solve our current technologies. The introduction of abstract and the machines, which such as deterministic finite automata (DFA) and Turing machines, allows the research to model computation in a way that can be completed theoretically and practically. This is the structure of automata theory, which consists of combinational logic, finite state machine, push down automata, and Turing machine. Methodology. The methodology is the study of theory of computation involves the formalizing of problems and algorithms using the mathematical models. Complexity theory, for instance, uses like uh, P, like polynomial time, and NP, non-deterministic polynomial time, to categorize the problems based on how much the time or space is required for a solution. This is done by analyzing the worst case scenarios, providing the insight into the inherent difficult of problems. In computability theory, they focus on the identifying which problems can be solved by algorithms and which cannot be solved. This is achieved through the using of models such as Turing machine, which represent the most basic form of the computation. A problem is computable in its can be solved by the Turing machine, otherwise it can be classified into non-computable. Automata theory can be abstract and to the machines to represent a formal language where each type of the machine corresponds to the particular class of language. For example, finite automata can represent a regular languages, and while the context-free languages are represented by push-down automata. These models are crucial in understanding how the computers recognize the pattern and process the language. The result. A result of applying the theory of computation will demonstrate that certain problems are fundamentally unsolvable by the algorithms. For example, the halting problems, which asks whether a given program will terminate or run indefinitely, is proven and undecidable. This result highlights the limitations of computation and boundaries of algorithmic solutions. In the term of complexity theory, the result shows that the problems in the P class can be solved efficiently, while the problems in the NP class have no known efficient solutions but can be verified quickly. The relationship between these classes, especially whether the P equals NP, it will remain one of the most significant open questions in the computer science. Automata theory results will provide a clear clarification of languages and their corresponding computational models. Regular languages can be recognized by finite automata, while more complex languages such as context-free languages require a push-down automata. These results help in designing the algorithms for tasks such as parsing programming languages and developing a compilers. Discussion. The implication of theory of computation extend beyond the theoretical computer science, influencing the areas such as software development, cryptography, and artificial intelligence. Understanding the computational limits allows the research on focus of feasible problems and create an efficient algorithm for the real-world applications. One of the ongoing challenge in the is the determining whether there are efficient algorithms for the NP complete program. These programs are critical in the fields like optimization and cryptography and breakdown through. In the ideas could realization and computing the however the inability to solve the NP completes the problem in the polynomial time with the current knowledge create a significant barrier. In the automata theory, the practical applications such as abstract machines include the pattern recognition, lexical analysis, and the design of computational protocols. These models are foundational for understanding of the how system process information and making them essential for tasks ranging from the compiler construction to the network design. Let us come to the conclusion part. The theory of computation provides a deep understanding of what we can be computed and how efficiently the computation can be performed. By categorizing the problems into complexity such as determining the computability and modeling computations, automata research gains and insight into the capability and the limits of algorithms and machines. The study of complexity theory computation of automata theory will equip the computer scientists with the tools to classify the problems, optimize the algorithms, and design efficient systems. These theories can be backbone of much more modern computer science and are applied for wide range of fields, from the software development and to the data analysis. Future research in the theory of computation will likely focus on the unresolved problems such as P versus NP, as well expanding the understanding of quantum computing and its implication for classification of models. The ongoing advancement is in the field of with the continuous shape and future of technology and computation. Thank you for watching this video. Thank you.